look at question 2.3 now. So here they are saying it's a word problem. They are saying a ball is dropped from a height of 15 meters. Let's underline that. It bounces back and loses 10% of its previous height on each bounce. So you can see that it is dropped from a height and then it keeps on bouncing. Let's try to draw that here. So saying we have a height of 15 meters. Then this is our ground. So what they're doing, they're taking this ball and then it's being dropped. So it's gonna, which is being dropped, it's going to hit the ground. After hitting the ground, it's gonna bounce to a certain height. It hits the ground again, it bounces, hits the height, it hits the ground, bounces up, hits the height, or reaches the height, and so on. I don't know how many times it's gonna keep on doing this, but we know that from this point it goes down, it hits the ground, so it's not gonna reach the same height as 15 meters height, because now the speed has dropped. That is gonna be using to also, it's gonna be going up, so it's not gonna reach 15 meters. Like if you dropping a ball from the roof, it's not gonna come back to you on the roof on that same height. So this is the height here, that is the height, it is the height. But now they're saying it loses, so it bounces back and loses 10% of its previous height on each bounce, meaning that this height now is actually 10% less than this height, or same, like it's just 90% of this height, the same as losing 10%. And then this height is 90% of that height, this height 90% of that height. Let's just do that. So if we write it down, it would be, this one would be 15 times 90%, which is the same as saying it's 9 over 10. So 90%, and then this one would be 15 times 90%. But this is the previous height, but then it's going to be 90% of that previous height. The same here, it's going to be 90% of this height. But 90% is the same as saying it's 9 over 10. So if we write this down, we have initial height was 15. The next one was 15 times 9 over 10. I'm going to put it like this, 9 over 10. The next one is 15 times 9 over 10, but now it's the 9 over 10 of this previous height, so times another 9 over 10, which ends up being 9 over 10 squared. The next one is 15 times 9 over 10 squared times 9 over 10, which ends up being 9 over 10 cubed. And you can see the pattern that the next one will most likely be 15 times 9 over 10, 15 times 9 over 10 to the exponent 4, exponent 5, and so on and so on. Okay, now we can see it's a sequence, right? What kind of a sequence is this? It is a geometric sequence. Why? Because we are multiplying by this constant 9 over 10, but we keep on increasing the exponent of 9 over 10. So you know how the geometric is your AR squared. So you keep on increasing the exponent of R. But if you can't spot that, you can just test using your test, saying T2 over T1, check if it is equal to T3 over T2. I won't check because I can see that this is a geometric with R equal to 9 over 10 and A equal to 15. Now we've defined what kind of a sequence is this. We've seen that the heights, they form a sequence. Now they're saying we must show that the total distance that the ball will bounce cannot exceed 290. So let's look at this. So they're saying the total now means that we are now adding, right? We are now adding these terms. So we must show the sum of these terms, it's not going to be equal to the sum of this height will not exceed that number. But now we can see that, first let us note that this is should be noted that our R here is between -1 and 1, which means that our series will converge. What do you mean by converge? It means that it is actually decreasing, and you'll see that if you get these numbers, the first term is 15, the next one is 15 times 9 over 10, which is 13,5. The next one is 90% of that, which is 12,5. The next one is 90% of that, which is 10,9. So you can see that these terms are decreasing. So that's what you mean by converge. You mean that our terms keeps on decreasing, meaning that even our sum keeps on. The sum will obviously increase, but it gets to a point where the terms, they are too small. So for example, maybe T50 here would be a very, very small number, such as maybe 0. In fact, you can find what's going to be T50 here. So I can just show you this. So maybe if we check T50, it's going to be, we know it's going to be 15. times, so n will be 49 then. So 0.9 to the exponent 49. Actually, it will be 0.086. So you can see it keeps on decreasing. So this ends up making a small contribution to the sum. That's what you mean by converge. Okay. So now we must just find then S infinity here to show that this sum will end up, will not exceed a certain number. No matter how many terms you're going to add, no matter you're going to add 1,000 terms or 1 million terms, the sum will not exceed that. Now let's just sum to infinity because we know how many terms we're adding. So which is a over 1 minus r, and then our a is 15, and then 1 minus 9 over 10, which is the same as saying it's 15 divided by 1 minus 9 over 10, which is 150 meters. What did he say here? They said cannot exceed 290. So you can see that the largest sum you can get is actually 150, which is less than 290. Remember, sum to infinity will be where we are adding all the possible terms that we can have. So we have shown that this cannot exceed that number they gave us. Then the next question, 2.4. So just another tip, when you see these kind of questions which are word problems, first just to understand what kind of a sequence they try to put what they're telling you into numbers. And most of the time it's going to be, they love asking the geometric series. They'll say maybe something keeps on decreasing by 10% or by 5 over 4 each next term is just, and then maybe 4 over 5 of the previous term. That's going to be geometric. And then you need to look at what questions are they asking you. But your step one, put the word problem into numbers, check what type of a sequence that is. Most likely it's going to be geometric. And then look at what questions are asking. If they are saying, sure, that something will not exceed what, just know that it is sum to infinity. Again, it will be guided by your r. If your r is between -1 and 1, then it's convergent, meaning that sum to infinity exists, which means that the sum of all those terms actually is bounded. It's not going to exceed the sum to infinity value. Now the next question, 2.4, we are given these terms 25, 1 minus t over 3. So we're given the first term, n minus t over 3, this one is 5. Then the next one is 5, 1 over n minus t over that squared. The next one is just 1 minus t over 3 all cubed, and so on. They are saying for which values will the series converge. So we know how to answer the question. First look at convergent, write down the definition of a convergent series. It says r must be between -1 and 1. You get a mark for writing this, just a free 1 mark. Just let us calculate our r now. So now we find our r, which is t2 over t1, which is going to be 5 times 1 minus t over 3 squared, all divided by 5 times 1 minus t over 3. You're going to see here the magic, that and that cancel out. These the same basis, we're dividing the same basis, 1 minus t over 3. Subtract the exponents, you're going to get 1. Going to be left with 1 minus t over 3. That is our r value. We now take our r value, we put it here in the place of r, and then we've got this. So now I want to solve, want to find the value of r that will make this, the value of t which will make this r to be between -1 and 1. So when I solve for t, because they said for which values of t. So what we do, multiply both sides by 3, and then we'll get -3, 1 minus t is less than 3. Then we want to be left with a t, so we're gonna subtract, let's multiply by 3 even here, and then we're gonna subtract 1, subtract 1, subtract 1. If we do that, these two will cancel out, so then we'll be left with a -4 here, and then here we'll be left with a minus t. 3 minus 1 is 2. Now with minus t we want a t, so we divide both sides by -1, -1, -1, dividing an inequality. So what happens if we divide by a negative number? Your inequality direction changes. So you're going to have a 5 here, going to change the direction to be that. Here we have a t, change the direction, it becomes a 2. So meaning that our t is less than 5, but our t is greater than 2. Another way of writing this would be to say that t is between 2 and 5, which is much more readable. Then the next question, they're saying if t is 15, calculate the sum to infinity of the series if it exists. So they're saying if t is 15. Okay, it's the first question. If t is 15, calculate the sum to infinity of the series if it exists. Okay. So let's check. Now, if t is 15, then this series is not going to converge, because we said it's going to converge if t is between 2 and 5. So you can just say if t is equal to 15, the series will diverge, will not converge. So which means that sum to infinity does not exist, because now this by diverging means that your sum keeps on increasing like exponentially. So if you are going to add all the terms to infinity, you're going to end up getting maybe infinity as your answer. So sum to infinity does not exist here, assuming that we calculated this correctly. Yeah, they shouldn't be asking if the sum to infinity exists. In fact, if t is 15, I wouldn't even substitute it here, because I know that there will be no sum to infinity. That's just a free for marks. I guess then you have to explain why it will not exist, such that it will diverge. We can even add and say, because from 2.4.1, this series will only converge if t is between 2 and 5.